What are the black holes? Black holes are some of the strangest and most fascinating objects in outer space. They are extremely dense with such strong gravitational attraction that even light cannot escape. Albert Einstein first predicted the existence of black hole in 1916 with his general theory of relativity. The term black hole was coined many years later in 1967 by American astronomer John Wheeler. After decades of a black hole being known only as theoretical object, the first physical black hole ever discovered was spotted in 1971. Then in 2019, the Event Horizon Telescope (EHT) collaboration released the first image ever recorded of the black hole. The EHT saw the black hole in the center of the galaxy M87 while the telescope was examining the event horizon, or the area past which nothing can escape from the black hole. The image maps the sudden loss of photons, particles of light. It also opens up the new whole area research black holes. Now that astronomers know what our black holes look like. So far, astronomers have identified three types of black holes: stellar black holes, supermassive black holes, and intermediate black holes. What are the stellar black holes? Small but a deadly one. When a star burns through the loss of its fuel, the object may collapse or fall into itself. For smaller stars, those up to 3 times than the Sun mass, the new core will become a neutron star or a white dwarf. But when a larger star collapses, it continues to compress and creates a stellar black hole. Black holes formed by the collapse of individual stars are relatively small and incredibly dense. One of these objects packs more than 3 times of the mass in the sun the diameter of the city. This leads to a crazy amount of gravitational force pulling on the object around the object. Stellar black hole then consumes the dust and the gas from their surrounding galaxies, which keeps them growing in size. According to the Harvard Smithsonian Center for Astrophysics, the Milky Way contains a few hundred million stellar black holes. Another one is the supermassive black holes, the birth of the giant. Small black holes populate the universe, but their cousins, supermassive black holes, dominate. These enormous black holes are million or even a million of times as massive as the Sun, but are about the same size in diameters. Such small holes are thought to lie at the center of pretty much every galaxy, including the Milky Way. Scientists aren't certain how much large black holes spawn. Once these giants have formed, they gather mass from the dust and the gas around them, material that is plentiful in the center of the galaxy, allowing them to grow even more enormous in the size. Supermassive black holes may be the result of hundreds of thousands of tiny holes that emerge together. Large gas clouds could also be responsible, collapsing together and rapidly accreting mass. A third option is the collapsing of stellar cluster, a group of stars all falling together. Fourth, supermassive black holes could rise the largest cluster of the dark matters. This is a substance that we can observe through its gravitational effect on other objects. However, we don't know what dark matter is composed of because it doesn't emit light and cannot be directly observed. Intermediate black holes stuck in the middle. Scientists once thought that the black holes came in only small and larger size, but recent research has revealed the possibility that the mid-size, or we can say the intermediate, black holes IMBHS could exist, such as body could form when stars in the cluster collide in chain reaction. Several of these IMBH forms in the same region could then eventually fall together in the center of the galaxy and create a supermassive hole. In 2014, astronomers found that appeared to be an intermediate mass black hole in the arm of Spiral Galaxy. Astronomers have been looking very hard for these medium-sized black holes. Study co-author Tim Robert of the University of Durham in the United Kingdom said in a statement, "There have been hints that exist, but IMBHS have been acting like a long lost relative that isn't interested in being found. New research from 2018 suggested that these IMBHS may exist in the heart of dwarf galaxies. Observation of 10 such galaxies, which were previously unknown to science before this latest survey, revealed X-rays activity common in black holes, suggesting the presence of black holes of form from 36000 to 316000 solar masses. The information came from the Sloan Digital Sky Survey, which examines about 1 million galaxies and can detect the kind of light often observed coming from black holes that are picking up nearby debris. Black holes. What do black holes look like? Black holes have three layers: the outer and the inner event horizon and the singularity. The event horizon of the black hole is the boundary around the mouth of the black hole past which light cannot escape. Once a particle crosses the event horizon, it cannot leave. Gravity is constant across the event horizon. The inner region of the black hole, where the object mass lies, is known as its singularity, the single point in space-time where the mass of the black hole is concentrated. Scientists can see black holes the way they can see the star and other object in space. Instead, astronomers must rely on detecting the radiation black holes emit as dust and gas are drawn in the dance. Sometimes, as matter is drawn toward the black hole, is ricocheted off the event horizon and is hurled outward rather than being tugged into the maw. Bright jets of the material traveling at near relativity speeds are created. Although the black hole remains unseen, these powerful jets can be viewed from great distance. The Event Horizons telescope of the image black hole in M87 released in 2019 was extraordinary effort, requiring 2 years of research even after the images were taken. That's because the collaboration of telescopes, which stretches across many observations worldwide, producing an astounding amount of data that is too large to transfer by the internet. Shining light on binary black holes. In 2015, astronomers using the Laser Interferometer Gravitational Wave Observatory LIGO detected gravitational waves from merging stellar black holes. We have further confirmation of the existence of stellar mass black holes that are larger than 20 solar masses. These are objects we didn't know existed before that the LIGO detected them. David Shoemaker, the spokesperson of the LIGO Scientific Collaboration (LSC), said in the statement that the observation also provides insight about the direction a black hole spins as two black holes spiral around one another. They can spin in the same direction or in the opposite direction. These are the two theories on how binary black holes form. The first suggests the black holes in binary form and about the same time from other star that we were born together and died explosively and about the same time. Under the second model, black holes in the stellar cluster sink to the center of the cluster and pair up. These companions would have random spin orientation compared to one another's. LIGO's observation of companion black holes with different spin orientation provides strong evidence for this formation theory. What are the weird facts about the black hole? If you fell into the black holes, theory has long suggested that the gravity would stretch you out like spaghetti, though your death would come before you reach the singularity. But a 2012 study published in the journal Nature suggested that the quantum effects would cause the event horizon to act much like a wall of fire, which would instantly burn you to the death. Black holes don't suck. Suction is caused by pulling something into vacuum, which the massive black hole definitely is not. Instead, object falls into them just as they fall toward anything that exert gravity like Earth. The first object considered to be black hole is Cygnus X1, was the first subject of 1974 friendly wager between Stephen Hawking and fellow physicist Kip Thorne, with Hawking betting that the source was not a black hole in 1990. Hawking conceded defeat. Miniature black holes may have